So Bazoo and Nin, and welcome to the 9th installment of our GLIER Trust Virtual Seminar Series. My name is Savannah, and I'm a master's student at GLIER in Dr. Chris Weisner's lab at the University of Windsor.
And my name is Sandau, and I'm a PhD student in communication at Wayne State University.
And we are your hosts for today's panel.
To begin, we would like to acknowledge that the University of Windsor and Wayne State University sits on the traditional territory of the Three Fires Confederacy of First Nations, Anishinaabeg, Peoria, Miamia, and Mississauga Nations.
We as the Windsor and Wayne University communities would like to move beyond acknowledgements, and we would like to not only give our respect to the traditional territory we are on, but also commit to learning and growing, starting with our partnerships and collaborations moving forward.
Today, our panelists will be discussing topics related to their work, as well as providing advices for those interested in careers in industry or collaborations with industry partnerships. We as graduate students have prepared a list of questions and topics related to the environment sustainability, a sustainable energy future, career perspectives, research needs of organizations, and how we can facilitate collaborations to solve our most pressing environmental issues. We are pleased to have with us a group of panelists that have unique experience and currently work on a wide range of environmental topics. However, what they all share is the common goal of improving the environment and communities that they serve. And we are very grateful that they all are joining us today to share their perspectives. To make a welcoming environment for our panelists, we ask everyone to please turn on their cameras and give a wave for a brief moment.
Thanks everyone for doing that. So we're just going to go over a bit of Zoom ground rules right now. So now everyone in the audience, if you could put yourselves on mute and have your video off, that would be appreciated. Your chat facilitators today are GLIER and Smita. Please send your questions to them and they'll pass them on to myself and Sandau for the Q&A portion of the panel. This talk will be recorded and posted online at a later date, and we would like to ask our technical team to start recording if they haven't already. The format of the panel goes as follows. We will introduce the speakers and they will tell us a little bit more about themselves and the organizations, and then we will have an open discussion for about an hour. Everyone is encouraged to stay after the hour for a 30-minute Q&A where we will be taking questions from the audience. Before we begin, I would just like to announce that our next seminar, titled Eco-Hydrological Connectivity from Abstract Concept to Management Tool, will be taking place on Friday, March 12th. So we hope you can join us for this seminar. For anyone who missed our previous seminars or traditional ecological knowledge and our nonprofits and social enterprises panels, we've now launched our YouTube channel, which the link will be posted in the chat so you can watch our entire seminar series, which focuses on the topic of transformative change and environmental sustainability.
We will now briefly introduce each of our panelists, starting with Connie Lilley, followed by Ed Verhamme, Dr. Sandau, and Paul Weidman. As a follow-up to your introductions, could you please further describe your organization and some of its main objectives? If you'd like, please also share some projects you are currently involved in.
So we're going to start with Connie. Connie is the executive director for the Detroit 2030 district. Detroit 2030 is a free program for building owners and managers that assists with reducing energy and water usage, greenhouse gas emissions from transportation, as well as other sustainability initiatives. Connie has been working within the commercial built environment for 30 years, with the last 15 years focusing on energy efficiency and sustainability. Connie currently serves on the City of Detroit Green Task Force Group Energy Waste Reduction Committee. In 2019, Connie received the AIA Detroit Honorary Affiliate Award for her work with the built environment in Detroit. Connie has also received 2 awards from the National Association of Women in Construction Detroit. She has also served on the board for the U.S. Green Building Council Detroit chapter, committees for BOMA and IFMA. Connie is a lead AP and holds an MBA in Strategic Management with a focus on corporate sustainability and a Bachelor of Science in Public Relations and Journalism. Welcome, Connie.
Good morning, everybody. Thank you for having me. I kind of forgot what I wrote there. Okay, so goodness, our program has been together for 3.5 years. We launched 3.5 years ago. And it took us about 3.5 years to launch. So we are one of 24 districts across North America. There's 3 in Michigan, Grand Rapids, Ann Arbor, and Detroit. So if you can imagine, we collaborate a lot on our initiatives. And like Savannah mentioned, our goal really stems from the 2030 Architecture Challenge that an architect named Ed Mesria put out to architects, goodness, I don't know how many years ago, let's just say 6-7 years ago, and said, we should do a better job building and renovating our buildings. And he set a goal of reducing the energy and water usage, as well as the greenhouse gas emissions from transportation to 50% by 2030. So that's kind of where the year comes from in the name of our organization. We have a lot of other goals that we branch out into. We cover stormwater management, anything that you think a building owner in Detroit might need to face. During COVID times, we actually pivoted what we normally would help our building owners with and looked at ways to reopen safely and have a safe and healthy building, which is also a part of reducing emissions anyways. So it's not always just about our 3 metrics. We currently have 1,400 buildings in our area where we're measuring our reductions in energy and water, which we do through Energy Star Portfolio Manager. And we have about 200 buildings in our program. So the building owners sign up and we assist them with anything and everything for any green sustainable initiative for their building. So we have a large network of professional companies that support us, volunteers, industry professionals. So the value of joining our program is, first of all, for a building owner, it's free, but we bring a resource and networking and programs to the building owners to help them reduce the energy and the water, as well as if you do that, it reduces your operating costs. So that's a big part of our conversation in Detroit. Currently, some of the big projects that we're working on, we work closely with DTE, who wants us to reduce energy usage in our buildings, which is great. They're a big supporter of ours. So one of the big things that we're working with them is a pilot right now to help customers who have commercial buildings in Detroit be able to use, send their energy usage and water usage directly from DTE to Energy Star Portfolio Manager. So they can have an account and have it be this ongoing data transfer. Right now, people have to take their bills and sit down in front of their computer and type in all this information. And everyone knows you can't reduce what you can't measure. So you need to know your starting point, and then, so you should have an Energy Star Portfolio Manager account. And we help with that. So this pilot is about 30 buildings in Detroit as well as Ann Arbor. And if it does go through, it will be a game changer for us. One of the biggest issues in our industry is transparency on energy usage for the buildings. It's kind of a double-edged sword on where I go with that, because I'm trying to help our building members comply and understand. On the other side, it's really hard for them, so I have to kind of wear their hat with them wherever they're at. Same with benchmarking ordinances. We're working on one with Grand Rapids and Ann Arbor. All 3 cities are working on a benchmarking ordinance for commercial buildings. So while that sounds great for our district and something we should definitely support and move forward, our building members will be concerned, how do I do that? What does that mean for me? So we kind of wear double hats with that. We have 3 best practice groups, and we bring them together to help them learn what their facility type needs. It's very helpful for them to meet other people managing a building similar to what they have. So we have a venue museum group, a house of worship, and a multifamily. We're working with a couple people from Wayne State University here, as well as U of M, on our greenhouse gas emissions from transportation to and from our buildings. That metrics is a little bit behind on the work, but right now it's very timely, and we're starting to really see a push on that type of initiative for our building owners, as well as, the electric vehicles. So Ford and GM are involved in our program, and really, we're just trying to bring knowledge and information to our building members. We have 34 million square feet in our program, so it's a robust program with a full year of all types of, well, used to be in-person events, but not anymore. I'll finish with that. I do have, if anyone wants to talk about what's coming up on the horizon in this industry afterwards, I won't cover it right now because it's not something we're currently working on, but there are some trends and things that you could look at for what's coming down the pike in this industry. So I think that's all I have right now. I hope that was enough or not too much.
Thank you, Connie. Our next panelist is Ed Verhamme. Ed is an environmental engineer at Limno Tech, as well as the current president of the International Association for Great Lakes Research. He has worked on Great Lakes water issues for 18 years, where some of his projects have involved ecosystems modeling, harmful algal bloom management, and development and deployment of data gathering and monitoring technologies. Over to you, Ed.
Great, thank you. And hello to everyone out wherever you're at, and thanks for taking the time out of your day to be here today. It's these Zoom sessions, it's really great to replace as much of the in-person as we can. So it's great to see all of you. And in sort of leading up to this, I saw Connie, your name on here with the Detroit 2030 district, and I didn't know what that was. So I went and checked out your website. You guys have a really cool mapping application. I don't know what it is about maps that just really geek me out with information and what's going on. So kudos to your organization for having a really cool map. I'm a environmental engineer at Limno Tech in Ann Arbor. I've been there since I got my master's degree at Michigan Tech. So it's been a 16 years of being at Limno Tech, and I'm in the consulting sector, which has a lot of advantages of just getting a ton of exposure to all kinds of different clients. So from nuclear power plants, I've been at inside the screen houses for nuclear power plants that are sucking in 1 billion gallons of water a day to cool the reactor. I was out at the Toledo water intake a lot in the last few years, helping them monitor harmful algal blooms. I've spent probably 700 plus days out on the Great Lakes, about half for leisure and about half for work. So it's, I've really enjoyed being able to blend my, my life with the Great Lakes with sort of the science of the Great Lakes and how we monitor them. And I know we spend a lot in the classroom and in offices talking about these natural ecosystems, and I mean, there's really no replacement for just time spent out in the systems you're studying and the places. I'm sure, Connie, being in the buildings of your district is just, who are you actually serving? How do you go to work every day and just feel that you're connected to more than just your computer screen? So I've really enjoyed the opportunity that consulting has given me to, I'd say generically find solutions, but it's really helping people with things they don't understand. And my degree is environmental engineering, but whatever it is about the intersection of environment plus engineering, it involves almost every other discipline. I've spent time doing computer programming. I spent time thinking about the economics of the projects we're doing. I've spent time thinking about, we know why something isn't working, but why aren't people changing their habits? Why don't we see progress? So I think one message for me is, yes, everyone's gonna graduate with a degree in whatever field, but those field boundaries really dissolve out in the natural world, and it's more the people that that really stay. So I'd really, emphasize the people relationships, and those have led me to the professional organization that is IAGLIER, the International Association for Great Lakes Research. So how do we sort of gather, organize, talk about these ecosystems that isn't at our workplace? There's no boss saying, get moving or don't worry about that. So I encourage people to find outlets for their professional life that allows them to meet other people, see how other people work, find out what other cool stuff is going on, how can you work on that, and you just tend to just help act like a magnet toward people you want to work with when you're out in these professional spaces. So, the sort of trend in the last several decades is a reduction in people sort of contributing to these volunteer off the clock type organizations. And I mean, for me, those have been really invaluable contributions to how I can, be invited into that nuclear power plant of, what's going on. So anyway, I won't go too much longer, but it's great to be here. I'm happy to talk about the intersections of these careers and how we can learn more about how to do the work we love doing. So thank you.
Thanks, Ed, for that introduction. We're now going to introduce Dr. Sandau, who is the principal and owner of Chemistry Matters and is a founder and vice president innovation of both Statfist Analytics and Precision Liability Consulting. Dr. Sandau has worked in the environmental industry in Canada since 2004 and founded Chemistry Matters in 2011. Considered a boutique international environmental consulting firm, Chemistry Matters specializes in geoforensics, environmental forensics, biomonitoring, and arson investigations. He uses advanced data analysis, visualization, and compound identification to comb through large data sets, identifying patterns, causes, and origins in litigious chemistry issues.
Thank you. Thanks everybody for showing up and giving a quick wave at the beginning. I always find these presentations a little intimidating, speaking to a black screen. It feels like you're just speaking to a void. There's no feedback. I like the audience feedback, and hopefully we can all get back to that soon. But thank you very much for your time, and it's my pleasure to be here this morning. I'm based out of Calgary, so it's a little early for me, but I've had my coffee, so I should be good to go. Where I come from, I'm a chemist. I'm a PhD in chemistry, so all my work is chemist type stuff. And what I was able to do with my career is I started out obviously getting a PhD. I moved into government. I then went into the private sector and working for a consulting firm, and I did that for about 18 months and then decided that wasn't for me. I needed to have my own business, and now I have 3 of them. So I've become a bit of an entrepreneur in opening boutique businesses and in assessing environmental contamination. As a chemist, you wonder where your place is in the world because, as an engineer, you kind of know what you do when you graduate with an engineering degree, right? If you do civil engineering, you do civil engineering. As a chemist, you can just about do anything. And I'm always reminded of a SeaTac bumper sticker from, I think it was about 1998, which dates me a little bit, but that's okay. You can probably tell. It was "What in the world isn't chemistry" was the SeaTac bumper sticker. And that's really my mantra that's been for my company is I get involved in a lot of different stuff. I've worked on everything from methane monitoring and methane fugitive emissions, and that's with Scott Mundell at University of Windsor there. That's where him and I got to know each other and worked together a lot on chemical fingerprinting of sources of methane and figuring out if it's coming from leaking wells or other sources. I moved on to environmental contamination monitoring and fingerprinting, knowing where environmental contaminants are coming from and being able to advocate for that in a courtroom setting. So high-end science, but then you have to defend it in the courtroom, whether that's to a jury or a judge or just against other experts. So that, that's kind of fun. Then everything from human exposure monitoring. There's a lot of chemicals in our environment. And there's a lot of lawsuits that come up on, I've been exposed to a chemical, I'm sick. I need to be compensated, and making sure that the right people are getting compensated. There is exposure out there. but you have to be able to prove that. And so I do a lot of work on human exposure monitoring to assess whether someone actually has been exposed to chemicals or not. And even arson investigation, which is one of the fun ones that I'm going to talk about, is chemical fingerprinting of petroleum products and assessing where, not only if arson occurred, but where the gasoline was purchased from, which the technology is allowing us to do now with some of these advanced statistics and analytical chemistry procedures that we can do. So a couple of projects that I'm most excited about that sort of keep the gray matter going. And, consulting can be very boring. There's a lot of repetitive stuff that you do in consulting, and it seems pretty mundane for a lot of it. But if you stay at the front end of the consulting thing, you can stay engaged. And that's been my goal, is to try to push the science forward and make sure I'm on that front end, so that I'm discovering new things and adding to the science and moving it forward in the consulting world, which has been fun. And so one of the things I work on that I'm really passionate about right now is chemical fingerprinting and source apportionment modeling. So this is the combination of chemistry, environmental fate and transport, and then statistics that help tease apart those chemical mixtures and tell us where they're coming from and what proportion are coming from. And these are on multi-billion-dollar cleanup sites where we're fighting about cleaning up sediments in a harbor or a river, and you're fighting over $1 billion. So like 1% of $1 billion is a lot of money, and so there's a lot of bickering about who's paying for that 1%. So I find that it's really engaging, because it's using that cutting edge statistical software, trying to make sure it's meaningful in the chemistry and fate and transport world, and then defending that in a courtroom. So I really like that world that I'm working in right now. And then the other passion is arson. Not doing arson, of course, but solving arson cases, and being able to figure out like arson investigations are there's a fire, the investigators go out there, they see that it's caused by a human, or they suspect it's caused by a human. They usually bring in a dog to help them figure out where the accelerant or ignitable liquid residue is put out there. And then they bring it to the lab, they sample it, and they bring it to the lab, and they say, is there accelerant here? Is there ignitable liquid here? And that was step one. But I've been trying to take that to step two, is not only do I want to know, is there an ignitable liquid there, but I want it to be able to tell you exactly what it is, to the degree of what gas station it came from. And to do that, what we're using is multidimensional chromatography, or GC by GC, which allows us to separate all those chemicals out and get hundreds of chemicals. So gasoline is made up of 400 to 1200 chemicals. So it's not just octane. It's, you go up to the pump and you buy octane. It's not just one, it's like 1200 things. And we use those 1200 things to chemically fingerprint and hopefully point to a gas station. And, I'm not talking like if you're in the city of Windsor and there's, 150 gas stations, I'm probably not going to be able to tell you which gas station it came from. But when there's fires out in small communities and there's 6, 7, 8 gas stations, we can definitely fingerprint which gas station it came from based on that. So that's some of the places. And I work as an adjunct professor at Mount Royal and have a research group there. And we're developing those techniques, which are, again, have never been used before in the world, and applying them to real world case studies. So that's sort of where I get my giggles from.
Wonderful. Thank you, Dr. Sandau. Now our last panelist to introduce is Dr. Paul Weidman, who is a research scientist and a professor at the Great Lakes Institute for Environmental Research at the University of Windsor. His research group studies the effects of multiple anthropogenic stressors on water quality, nutrient cycling, and lower food web dynamics among benthic and pelagic algae and invertebrates in freshwater ecosystems. Multiple stressors include air pollution from industry, nutrient runoff from agricultural lands, cities, invasive and prolific algal and invertebrate species, and climate change. Current study sites include nearshore regions and coastal wetlands in the Laurentian Great Lakes, mountain streams, and lakes in British Columbia and Alberta, a large network of boreal lakes in northwestern Ontario, and several larger lakes in Western China and Indonesia. Ultimately, his work is aimed at understanding the structure and function of freshwater ecosystems with the goal of mitigating the impacts of human activities on the services these ecosystems provide for society, such as productive fisheries and clean drinking water. Over to you, Dr. Weidman.
Oh, thank you for the introduction. Yeah, it's wonderful to be here with you today. I appreciate the invitation to come, and it's fascinating to be on a panel with people with such different career backgrounds. I think Ed Verhamme and myself might be the closest aligned, although I don't work in the industry, in the consulting industry. I have clients who are consulting companies. So as a freshwater ecologist, yeah, I study, mainly, certain aspects of lake streams, and now I'm doing some work in coastal wetlands in the Laurentian Great Lakes. And so I'm interested largely in, pollution and climate change and land use and how these things affect water quality and bodies of water. So currently I've got about 5 sort of areas of work where I'm engaged in. It's largely the group of 7 postdocs and graduate students I'm working with, and plus my own work. In the Laurentian Great Lakes, I have a postdoc, Joanne Song, who's working with Toronto Region Conservation Authority on a MITAX postdoctoral fellowship. And so MITAX is an interesting agency that explicitly tries to link university research with industry. And so Toronto Region Conservation Authority is an arm's length branch, a non-governmental branch of municipal government, essentially in Ontario, that is responsible for conserving and affecting land use change and protecting water on the landscape and in the Great Lakes. And so Joanne is working on this problem of prolific nuisance algae that grows on the bottom of lakes, especially in clear areas of the Great Lakes, and washes up on shores and fouls the shorelines and degrades water quality. And as Ed Verhamme mentioned, like the Pickering nuclear reactor is one of the stakeholders in this work, where this algae plugs those water intakes Ed was mentioning, and causes like really expensive shutdowns in the nuclear reactor. So we're studying the ecology of that nuisance algae. I also have another postdoc, Dylan Shaw, who's working with me on looking at the ecophysiology of invasive mussels that are pretty well known. The zebra mussel invaded the Great Lakes in the late 1980s and was replaced by the quagga mussel. And the activities of that mussel on the lake bottom are what we're studying. And part of that issue is to determine how those mussels draw nutrients from the water column, but also how they contribute to the growth of that prolific algae that I mentioned earlier. Also working on Western Lake Erie being one of the most productive fisheries areas in the Great Lakes. And I have several students that just completed their research, and one postdoc who's starting to look at linkages between the phytoplankton and zooplankton community in Western Lake Erie and juvenile fish production in the lake itself and in coastal wetlands that margin the shorelines of the Great Lakes. I guess I've got a few other projects that I won't mention in any detail, other than, I'm working with some researchers in China and on large-scale water diversion projects in Western China, which isn't industrially driven, but it's large mega projects being conducted by the government. And we're looking at water allocation. We have a student, Mingjing Wang, who's working at Yunnan University, doing her MSc with Professor Wei Gao there, and looking at the effects of water diversion on water quality of a pretty highly eutrophic lake in Lake Tianqi in Western China, in Yunnan province. My PhD work was not industrial related, but it was on mountain lakes in the national parks in Alberta and the communities of invertebrates and algae that live in the lakes in relatively pristine parts of the world. And we're looking at how climate change is affecting the structure of those ecosystems and the water quality in them. But my more recent work in North Coastal British Columbia, I worked on very small streams that run off, mountain streams that run off into larger rivers and salmon-bearing rivers in the estuary in near the town of Kitimat, which is a part of North Coastal BC that's experiencing a lot of industrial development. There's several major multi-billion-dollar projects that are developing export of liquefied natural gas facilities on the coastline, and that's being piped, extracted from Alberta and Saskatchewan and piped across the provinces through BC. This is the plan for several of these facilities. And there's lots of effects from atmospheric emissions at the end of the pipeline from those facilities, and of course lots of concerns up the stream towards Alberta. Anyways, we were looking at the effects of the industrial emissions of a aluminum smelter and projecting some of the effects that might happen as a result of these liquefied natural gas facilities. And Dr. Tim McGuire, who's now a postdoc at NOAA at the University of Michigan, worked with Scott Mundell and myself on work following up from that project that I started, which is ongoing. So it gives you a sense of some of the different projects I'm working on, and I think that it should blend nicely into our, we're talking about the different sectors and organizations that we all may have worked in. So thanks.
Thanks for that introduction, and thank you to all panelists for the introductions too to our discussion today. We'll now move on to some other panel questions that we have prepared, and just a reminder that throughout this discussion, if our audience could send questions to our chat facilitators for a Q&A after this, that would be great. Sandau, I think you're on mute.
All right. Our first question to the panel is, the graduate students in our programs are interested in understanding different career pathways. Please share with us differences with working in industry, research organizations, and other partners you engage with in your various roles and projects. Anyone can speak first.
I can go ahead. In our industry, data is very important, and when we launched the Detroit 2030 district, all districts create a baseline of energy usage for their buildings to measure from. And it was kind of eye-opening to see how little we knew of this. Energy usage, oops, there we go. 1 second, there we go. Data transparency is or just data in general is a very good area to get into, to study, to help us understand where we're at and where we're heading and where we need to go as far as energy and water usage. I would also say that the other areas that are up and coming are not just emissions that buildings might put out or cars, but carbon, embedded carbon and sequestering carbon are both very hot topics in the life cycle assessment for how to, to build the building itself, and where did it come from, and what type of emissions did you create while you were making it, and how did you get it there, and what do you do at the end of the life cycle of that building. So I think those are a couple good areas that I see in our industry that need help. Building owners and cities in general need help with understanding their environmental responsibility. And the hard part about what I do is that everybody's at a different place with it. So if you are a building or facility manager or owner, you may know absolutely nothing about what is coming down the pipeline and what you need to do. So we help those building owners. But, you get people who have been working on a building for 30 years and they've never dealt with this. It's a new world for them. And a lot of them don't really want to make a move and don't really want to learn. So it's an open, sky's the limit type industry of how building owners and facility managers need our help. And yes, we have the big companies like CBRE and Jones Lang LaSalle and stuff that can help with this. But in general, people don't have a lot of money to put towards this, but they still need to do it and figure out how to do it. So that's just my little input there.
Sure. Yeah, I can go next. So just with the differences between these sectors, I was thinking of this more as, you know, in that people relations world, where is someone responsible to society? And it, you know, I have this feeling that industry tends to wrap that boundary around the company. So everyone internal is sort of working on products or you know, whatever their sort of service is, and that sale is the sort of boundary to the public, and you're kind of accountable through the more of the commercial aspect to the checks and balances on what people want to buy your stuff. When you get to a research organization, I tend to see people cluster in these research groups, and it's kind of the research group accountability. There's a lot of collaboration. You get research groups connecting to each other. You get papers published. You know, there's just a different means of how you communicate to the external world. And then the nonprofit sector, I think, has a, you know, I'd say more of a direct accountability. You know, they're out in the community. Their bottom line isn't dollars, it's impact on the community. And so, I mean, as a consultant, I tend to, you know, I work for all those organizations, and I really do see some fundamental, you know, what is your relationship to society, and where do you think you would fit best in what I described? And I mean, these aren't hard and fast rules I'm saying, but it's clear when I look across how people view themselves in relation to the rest of the world. There's clear differences in how those types of organizations operate.
I'll go next. So, you know, the career paths as a graduate student, you know, you're not pigeonholed to academia, and I think a lot of academics get caught in that. Once they do the PhD, they get so in depth in their research and know so much about a topic that they feel that they have to continue on because they've learned so much. And it's a hard feeling to shake, because you have spent 4 or 5 years researching something so specific that it's hard to give up. You know, you don't want to give up your baby. I still read papers on the topic I researched during my PhD, and I don't do any work on that topic anymore. I was measuring metabolites of PCBs and polar bears and bald eagles and stuff, and you know, I still read all the papers that come out on that, but you know, I don't do any work on it. But I just can't let it go, because it's just it was so passionate about it at that time. So you know, my career path went from a PhD, and you know, I think we'll talk a little bit about recommendations for grad students for looking for a career. But you know, I was able to present internationally, and I got to know people in my field. And then I got the job offer of a lifetime, and I was invited to come work at the Centers for Disease Control in Atlanta, Georgia, right? And as a chemist that measures stuff and things, working at the Centers for Disease Control in the world's best laboratory to measure human exposure, I wasn't going to say no to that. So I lived down in the States for 4 years working there, and it was a fabulous opportunity. And I only got that because I presented, because I got out and made sure people knew about my work. So that would be my one big thing for all researchers right now and grad students, is get your knowledge out there and share it and present, because you know, that's where you're going to find a job, and that's where people are going to find you and see you talk and go, wow, you're a good communicator, I'm going to hire you. So I worked there for 4 years and started having babies, and my wife and I decided we wanted to move back home and live closer to family. And so I had to become a consultant, which was you know, hard to do as a researcher, because I felt like I was taking a step down. Sorry, all the consultants out there, but it felt that way, right? Because you're like, you know, I had to become, you know, a hired gun, or you know, this consultant that wasn't on the front end of science. And I managed to do that for about 18 months working for another company. And then my drive sort of kept me going, that I wanted to do something better, and I wanted to apply some of the science I had learned and I thought I could apply to the consulting world. And that's when I started my first company. And once I started my own company. That was it for me. I was free. I could do what I want. I collaborate with the university. I work with Scott at the University of Windsor. I work with Dr. Gwen O'Sullivan at Mount Royal University. I worked with the University of Calgary as an adjunct there in the engineering department. So I was able to stimulate and work in a research facility and make sure I was still contributing to research, but still, pay the bills with the consulting. And consulting does pay well. So that was another, benefit of working in the consulting industry is it does pay very well, and it's really enjoyable. And the one thing again about consulting, which is kind of neat, is that you're always working on different stuff. You have a field of expertise, but there's so many things that you can apply your knowledge to. And something Connie had mentioned and that I had forgot to mention is about data. And I think there's a huge opportunity for anybody coming from graduate studies right now, no matter what field you're coming from, is the understanding of data, how it works and how to look at it and how to visualize it and how to communicate it. And that doesn't matter if you're a chemist, a biologist, or an engineer. If you know how to handle data, communicate data, and talk to it, you're going to have so many things you could do. And I'm working on transportation data right now. Like, what does a chemist have any? Why am I working on stuff that's coming from engine, monitoring engine performance? But because I know data so well, it was easy to transition. And that's how that, I would say that a lot of my job has converted over into the, data communication, data visualization. And that's for one, to help people understand. And, I'm communicating to the courtroom or plaintiffs, lawyers, or, a jury. You have to be able to communicate pretty complex stuff. And the way to do that is to be able to develop visualizations that are easy to understand.
Okay, I guess I'll jump in. I've worked with a few different sectors. Like I guess during the early part of my career, I was exposed to freshwater ecology at the Experimental Lakes area in northwestern Ontario, which at the time was operated by Fisheries and Oceans Canada, the federal government, and so it was quite a unique and inspiring experience that really fit my, interests in the outdoors and nature and water and lakes and streams and bugs. It just gave it a framework. I just found it extremely fascinating. And I switched my, early academic path from that was aimed at law enforcement and parks management to doing a degree that allowed me to work on the physiology of algae in lakes and the effects of ultraviolet radiation. And so from there, that environment was pretty pure research, but it had, it was unique in that most of the large scale experiments at that facility were directed towards real important environmental problems, such as eutrophication of lakes with nutrient pollution, the acid rain problem which related to the emissions of sulfur dioxide, which is particularly bad in Eastern North America and Europe, and problems such as mercury emissions and release from flooded wetlands from hydro reservoirs, and so all very applied research problems that had real world implications and made direct contributions to legislation in Canada and the US. So that was really my inspiration for getting started. And then I went on to do a master's in Great Lakes research, working on invasive mussels in the Great Lakes and how they were altering nutrient flows and water quality in the lakes. And switched again for my PhD, worked mainly in the mountain lakes in Alberta, and there I was embedded in I worked inside 3 national parks in the Rocky Mountains, Banff, Jasper, and Waterton Lakes National Parks. And so there I was interfacing mainly with other researchers and Parks Canada staff. And the goals or the impacts that you can make in that type of environment really relate to conservation on fairly specific scales. They're large in terms of the national parks, and the species and populations of animals, fish, and in my case that are subject to or threatened or species at risk due to climate change, overfishing, invasive species, introduction of non-native species in lakes and streams in the national parks. So there, the outcomes were more applied, although at the time, my work was pretty research orientated, and now I'm sort of doubling back and trying to make some more applied contributions in areas like this that I've worked in the past. And I've also worked with fisheries and oceans research facilities in British Columbia, the Cultus Lake Salmon Research Lab, and which is a very research orientated government research facility. And but I was embedded within fisheries and oceans a salmon hatchery in north coastal British Columbia. And so there's some research elements to it, but it's a very applied environment where, that branch of Fisheries and Oceans Canada is really focused on trying to rebuild and replace extracted salmon from the environment that people, for commercial fishing and recreational fishing that extracts salmon from their goal, whether it is to offset some of those effects. And so much more industrial sort of feel to the working environment, where the day-to-day sort of goals and objectives of the people working around you were very applied. And so I found that quite an interesting throwback to some of my earlier days working in industry and agriculture. So, and now I'm working with colleagues at the Environment Canada in Burlington, Ontario. So they're at the Center for Inland Waters. Again, it's more of a pure research environment. So during, I had the opportunity, as I mentioned, like the MyTax Fellowship in Canada is directly tries to link researchers with industry. And so I for my postdoctoral work, I pursued one of those grants, and I worked with, ended up working with a small environmental consulting firm, and our main client was the Haisla First Nation, which their traditional territory is located near the town of Kitimat in north coastal BC. And there we're looking at, there was recently an expansion of an aluminum smelting facility that's been there for over 60 years, and they underwent a multi-billion-dollar upgrade to that facility, and associated with that, there's increases in sulfur emissions in the land, in the atmosphere around the smelter. And so there was several large cumulative effects assessments that looked at the impacts of those emissions on soils and lakes in the area. And I was hired by an NGO, an environmental NGO, initially to just review and comment publicly on an effects assessment for a liquefied natural gas facility nearby. And so those facilities where they're cooling natural gas that comes in the pipeline to the coasts, and they cool it down. They require quite a bit of hydro, and they burn natural gas in order to cool and liquefy the gas for export in marine shipping. And so those are expected to produce more nitrogen emissions into the local atmosphere. And so these are relatively pristine areas that don't experience a lot of other emissions, industrial emissions that are, quite common and prevalent in other parts of North America in terms of sulfur and nitrogen release. But so the opportunity to look at a localized problem and in isolation of other sources of pollution. So, there, that was one of my more recent experiences that was really multi-stakeholder orientated, and so, yeah, there was a lot of different experiences that were quite unique and eye-opening compared to having worked in a more research background up until that point. So. I guess some of my experiences were it was, you know, that opened a lot of doors in terms of being able to conduct a project and find funding and pursue a problem that I thought was important. Although working with multiple stakeholders, you know, comes at, there's challenges with that as well. It's relatively easy to work away on a very focused research project where you might produce knowledge that's important and contributes to a broader body of knowledge that is that directly applies to, you know, making, you know, mitigating the effects of human activities in the environment. But when you try to work with across stakeholder groups, every group has their own culture, their own expected deliverables, their own goals. And so you just have to be careful about, I found that, of being really clear what you can and can't do within the bounds of a research project, the timelines, and make sure that, you know, there's definitely ways of managing all those different, you know, slightly different interests and objectives. But yeah, it takes real experience to be able to anticipate what people are looking to get out of a real applied research project, and to make sure, you know, all the stakeholders involved are engaged and you know, and benefit from the work. And working with the First Nations, I could talk more about that maybe further down in the conversation, but that comes with its own set of considerations and opportunities, which are really fantastic, and I'd love to talk more about.
Thanks everyone for your responses to that question. So our next question is, the broader theme of this panel is connecting industry, research, and communities engaged in environmental sustainability and energy issues. What do you think are some misconceptions that the general public has about the work that you each do? How can we better bridge these misunderstandings?
I can go if you want. So what I found really interesting about, we're a private public organization. So we bring together communities, business people, municipalities, building owners. We bring together everybody to talk about our challenges and work on solutions. And what I really was happy to see is that people are really willing to work together. And I feel there's a big shift on how we work together to get things done that was not there in the past when it comes to this industry. People are willing to learn and to work together. So that's a lot of what I do on the daily, my daily job is just getting some people together in the room that maybe wouldn't have been together in the room. And it doesn't always lead to exactly where you want it to lead to, but conversation and opening the door to conversation is the start of everything, and a movement, and getting people to learn more about our topic of sustainability and reducing energy. You'd be surprised how many people how much they don't know. If you're working in this industry, you know about this industry and energy usage and sustainability, but if you don't, it's a big start for you and a big eye-opening experience. And if you think about it, they now have to take this journey and start this journey that they weren't planning on. And you know, once you start learning about buildings and energy efficiency and whatnot, it's ongoing, it's forever changing, there's no end to it. So people that aren't learning about this yet or haven't, and you're just introducing this idea to them, they have to shift to where they're at. So but most people are willing to, and it's really encouraging what I've seen.
Could I just ask a question, Connie? You mentioned earlier in your introduction that you know, one of the barriers that you're experiencing is I think energy usage or transparency in terms of energy usage with large buildings. And I think we encounter this with managing nutrient inputs into the Great Lakes and into water bodies in general, is with the agricultural sector. There's there's an issue of privacy, and scientists, we really want to gather and aggregate as much data as possible so we can get an accurate picture of what's happening on the landscape. But when it comes down to real small specific parts of the landscape, those include individual farms. And so there's issues of privacy and monitoring, research and government monitoring exactly what farmers are doing. I don't know, could you just talk in general about what it's like to grapple with that problem in your sector?
It's really interesting because I have found that when somebody wants to be transparent or not transparent about their energy use in their business or on their building, it really comes down to them personally and where they're at. So for instance, General Motors shares their energy usage with us, right? And then we may get another small building owner of, say, I mean the Renson, right? I can tell you how much energy use the Renson uses in Detroit, 5 million square foot building. And then you run into the situation where you have a 50,000 square foot building and they're like, nope, we're not telling anybody. We're not sharing it with you. So it runs the gambit, and the size of the company or the building is kind of irrelevant to if they're going to share or be open. It's the people that are in the company and in the business, if they see this as an important thing to do, right? It's getting a lot better. When I first started 10, 15 years ago on this, people thought that myself and other people working on it, we were all just tree huggers, which is a great byproduct of what we do. But there's such another huge side of it, which is reducing energy costs and whatnot. But it's getting better. It's a big change. I honestly never thought, I didn't even think we'd get off the ground in Detroit, because we were doing this before Detroit came back, working on it. So to see it go off the ground and people starting to be more open about it, it's good. However, just an example is a benchmarking ordinance. If we pass one in Detroit, we're going to ask building owners to report their energy usage. It'll be an ordinance, and it's a way to get them to comply, but not everybody's going to be happy about that. If you're a progressive company and you understand sustainability and why we're doing it, you're okay with it. But then you're still going to get the people who haven't gotten there and may never get there. But this is why it's nice to work with all of you college students, because you're setting the work you're doing now for the future. And we're really grateful for that. I hope that answered your question, Paul.
Yeah, this is it. I'll just build off of the sort of the cost and environmental sustainability question. What I encounter is people always associate environmental conscious with extra costs. And I think science, data, everything proves that if we protect the environment, we protect our relationships to water, we get more sustainable communities, we get more equitable distribution of resources. So I think I'm always really pushing back on that cost. And I think a lot about the some of the traditional ecological knowledge, where they try and plan out multiple generations, not just next year, what's our annual plan for our energy budget? It's what's the next generation, several generations out. And so when you push that decision horizon further out, the environmental question just becomes, it's not even an issue to talk about. It's like, of course we're going to have a sustainable energy. I just walked into my parents' house over Christmas, and I don't know why, but it had been a year since I had been there almost. And I was just struck at how many incandescent light bulbs were in the house. And I literally ran to the hardware store, bought as many LEDs as I could fit in my shopping cart, and replaced every light bulb in their house. And I don't know what struck me of why aren't we doing this more often? So, the cost becomes secondary when we know the life cycle energy costs and the raw material. So I'm always just struck at the timescales at which people evaluate that tree hugger mentality. So.
I think another thing I just want to throw in is that with the younger generation coming up, we won't have as many challenges as we do right now. Because I think when you talk to somebody a bit older about sustainability, it's threatening to them because they take it as you're telling them how to live their life, or you're telling them what they should be paying attention to that they haven't yet. And it's slowly changing, and the more we can talk about it and the more we bring up the operating costs or the the benefits financially to doing it is also helpful. We know it's helping the environment. We don't have, that doesn't have to be the start of the conversation. It could be about a financial side now that it's more beneficial financially to do it.
I guess to go on the question of misunderstandings, I'll start off with consulting. A lot of the misconceptions of consulting in my industry is that I defend the big bad guys. My job is to get them off the hook, and I would defend that I'm not. I'm usually working for the big bad guys because they pay my bills, and that's great. But it's what it is defending good science, and that's really how I go to sleep at night, is that you're trying to present good science and good scientific textual, good science facts that are basis of your claims. And when companies are fighting amongst each other, nobody really cares. They can fight and spend as much money as they want fighting against each other on who's going to pay what. But when it becomes a plaintiff that thinks they've been exposed to a chemical versus a big monstrosity company, everybody obviously gravitates towards those plaintiffs. And I think it's our job as scientists to provide sound advice and help those people understand what's really happening. Don't get me wrong, there are plaintiffs that have defensible accusations and they have been exposed, and they do need to be compensated for such. But most times they've been misinformed, they've been given bad information, bad data, and now who's responsible for more of the damage that's caused there? Is it the company that might have had an industry that released a chemical in the environment, whether they were exposed to or not? Or is it the people that are making those people think that they've been exposed, and now they're having trouble sleeping at night because they think they're suffering from something? And so I like that area. That's the fun part about communication about science, is what we know and what we don't know, and how to prove someone's been exposed, and trying to explain to the outside stakeholders or plaintiffs what's really happening in the science world, and having good scientific knowledge to defend that. And then connecting that back to the sustainability side of things, and I think this is going to lead into the next question a little bit, is the energy, we talk about energy sector and the sustainable future, and I'm an Albertan, so guess where I'm coming from. But oil and gas is still necessary, and we still need it. And I find that the transition has to happen. We all know that. All the oil companies are transitioning over too. They're going into sustainable energy, but there is going to be a transition period. It's not instantaneous. And if you want to institute change and you want things to move, you have to make better personal choices and know where all your products are coming from. Where are we getting our photovoltaic cells, and where are we getting the rare earth elements that build our solar panels, and where are we getting the metal to build our wind farms and our ocean turbines to generate electricity. Those come from resources that are being mined somewhere and are being exported. There's a carbon footprint involved with them to generate them, to keep them operational, and you have to keep that in mind when you're talking about this shift. And I don't think hopefully there's not too many people that don't believe a shift has to happen, but it does take a bit of time. And I always encourage my children to make better choices. Like, if you don't buy so much crap, like you're wasting resources. There's plastics being wasted all the time. Guess where that comes? That comes from the petroleum industry. If you want the petroleum industry to slow down, stop buying plastics. And that's all our products. That's our plastic bags. That's all of this stuff. So you do have an ability as an individual to transition and cause change. But that has to start as individual choices, not just sort of saying, that big bad oil industry, stop producing oil. Well, stop buying stuff that uses oil, and the oil industry will transition.
That goes back, can I just say one thing? That goes back to what I was saying about whether a company or organization wants to share their energy usage with us or get on board with us. It's them individually. It clicks in their brain what sustainability is about, why this is good, not just for my company, but for everybody. And if you're not there, then your company's not going to be there.
So we're running a bit short on time, and I know, Paul, you haven't had like the opportunity to add to this question. So do you have any quick thoughts? And then maybe we'll move to the third and fourth question, and everyone could just say one or two quick thoughts about that.
I think in terms of, yeah, I'll just be brief. I think in terms of misconceptions, I can usually sense pretty quickly when I explain my work to the public whether where they're coming from in terms of their receptiveness to their level of concern for environmental problems, especially water-related problems. And I guess to try to keep conversations focused on being effective in exacting change, I definitely try to put my work in context of real tangible improvements in and advancements that have been made in my field of science in terms of like real classic examples of like acid rain legislation, legislation that was used to basically cap and trade in sulfur dioxides and was very successful in doing so, or similar strategies between Canada and the US for and international agreements to reduce chlorinated fluorocarbons and their ozone depleting effects. Similar environmental research was fed directly into international agreements about mercury emissions, and that that mercury that emanates from coal-fired plants and flooded wetlands and reservoirs, and how it's transported through the atmosphere in concentrates in cold parts of the world, like the Arctic, and how Arctic food webs and indigenous people are really disproportionately affected by those emissions. So there's been major advances in environmental science and that have translated to real effective legislation. And when it comes to the problem of climate change and greenhouse gas emissions, I think that, on one hand, the problem is more complicated, nuanced, more deeply embedded in our social economic systems than any problem that we've ever faced before globally. But I think that, if we stay focused on what's worked in the past, even though those problems may have been less complicated, I think they're good models for what we can do in the future in terms of ongoing research and effective policy and legislation. And I could point some people to some real effective environmental economics communicators, at least in Canada, who talk about this problem in really easy to understand terms. But I could add that to the conversation later. Thanks.
As you're running out of time, we have to go into the Q&A session, but still we can have a little time to talk about the question number 3. Drawing on the examples from work you do, what are dimensions or steps we can take in transition towards more sustainable energy for the future? That's our third question.
Yeah, this is Ed. I have a quick answer to that, is get involved in your local politics as much as you can. Just keep repeating over and over. The environment's important. We need to keep planning. We need to keep pushing. So I think I'd like to see more scientists and engineers get out in that politics space, because I see that being the stop on measures of progress for a lot of other sectors, what research is funded, how we enable simple ordinances in our city to push communities in a direction. There's easy state laws that could say we need to, all energy bills are public information. and everyone can go and see who uses energy. I mean, we do it for taxes. I know how much my neighbors pay in taxes. Why isn't your energy or water bill in that same category? So politics is my answer.
I would second that. Policy and ordinances are so important. That wasn't even my background. I really didn't know much about it. And it's over the last couple of years, such an important topic and understanding of how we move forward with energy reduction. And like I said, we're working on the benchmarking ordinance in the city of Detroit, which will start with municipal buildings and then go to actual other building owners. So, but policy and ordinances are very important because there's going to be a certain amount of people that will probably not do anything until that happens, until they're kind of made to do it. So I agree with that.
I guess I would jump in and just say that one thing that came to mind when I was thinking about this question was just the role of science and research in government decision making. And there was a really good example that I really call back to in lectures, sometimes with undergraduate students, was in 2012 in Canada. There was the federal government at the time brought in this sweeping changes to environmental legislation through this omnibus budget bill, Bill C-38, which changed a couple of the most important environmental laws in Canada, including the Fisheries Act and the Species at Risk Act, and it also reduced funding for a couple of long-term environmental research stations that have made huge contributions to some of the environmental problems I mentioned today. And there was also, along with that, there was this government policy decision or initiatives to really limit and make it difficult for public sector scientists to talk to the public, talk to the media about the research that they were conducting. And it's pretty well understood that the motivation there is a problem with governance, and it's hard to create and maintain an effective government that can get things done in short amounts of time and produce effective legislation. And if you have, it's hard to herd cats, if all the cats are running in different directions, it can really dilute and confuse the messages and the initiatives that government is trying to achieve with public funds. So that's part of the problem. But when it comes to the role that scientists play, like academic researchers should feel pretty free to express their minds about research and public policy. But with public sector scientists, they're walking a different, they're fulfilling a different role in society, and I'm sure it's different in Canada than it is in the US. But anyways, the long and short of it is that there was substantial pushback in Canada against those initiatives, and the subsequent government, rolled back some of the changes to those environmental legislations that I mentioned, and and freed public sector scientists to speak more openly with the media about their research and the implications of their findings. Not to say that there isn't a nuanced discussion to be had here about the role of public sector scientists and how that's different from academic researchers or different from industry researchers. But I just think it's a good example of there was real active engagement from the public. And I think there wasn't a short-term memory for that problem. And I think it really played a role in this following federal election in Canada. And not to say that, I'm all that to say that, if you get engaged with environmental and sustainability issues in government, you can affect change, but it requires that that people aren't apathetic and people are engaged. And there was lots of good public communication of science that came out of that issue from researchers in Canada who really explained what's the importance of the Fishery Act and why we not only have to protect numbers of fish, but we have to protect the habitat where those fish are dwelling. And why is it important not to just look at large charismatic, fish that grab our attention like salmon and tuna or in the offshore, but we have to look at small, plain, not very exciting little minnows that live in small streams and feed large fish. So anyways, that's just comments on the role of science in government decision making.
And I'll go real quick. I agree with the other panelists on this one, so I won't reiterate what they're saying. But again, I go back to my last comment about, you know, our personal choices. And, you know, I do think that we as a society have to recognize that everything comes at an environmental cost. So a sustainable future is about recognizing that everything you do, or the food you eat, the type of food you eat, the iPhones that you buy every time they come out, the new sunglasses you have to have, or the, you know, the 18 different pairs of jeans that you need to have, all have an environmental cost. And if you're not making those decisions and acknowledging the fact that those have an environmental cost, I don't want to hear you talk about a sustainable future, because you're not thinking about it. You're protesting the oil and gas industry, but you know, you have 27 pairs of shoes, or you know, you're buying makeup and have, you know, a whole bunch of different things. I'm picking on ladies now, but men are just as bad. You have to know that there's an environmental cost to everything that we do, and making better decisions personally is our number one thing that we can do to help have a sustainable future. And then the other thing as young scientists is we need to educate people that there is an environmental cost to all of this, and make people understand that, you know, when you buy those cell phones, that, you know, how much carbon footprint and rare earth elements and all these things that go into building those every year, and you're just throwing them away because you need the newest and greatest. So it's our job as scientists to make sure others and the general public understand that, and that should be our scientist roles.
Thanks for all those answers. So I think we're going to try to squeeze in a couple audience questions now. So I'm going to skip the fourth question, as most of you have already provided some great advice in the other three questions. So Sandwin, do you want to ask the first question from our audience? I think you're on mute.
We have a question for Dr. Sandau or Dr. Weidman. Kate asks, as a scientist, what is your experience communicating your science to a room full of non-scientists that do not necessarily understand your science, but need your expertise? I hope the question is clear.
I'll go first. I love it. That's my favoriteest thing to do, is to help. I take it when I'm in a courtroom and I'm talking to a group of jury members, or I'm speaking in a public stakeholders. There's nothing to hide. Like, I think science, you can be completely transparent, and I love to be able to try to explain the fundamentals of everything. I've explained high resolution mass spectrometry quantification with isotope dilution, right? Like, foreign things to everybody, most people that would even, you know, be in that area. And I just think it's a huge challenge. It's being able to explain stuff to get them to buy in, and you know, like, I'll take it to my statistics stuff. When you're explaining multivariate statistics, you don't need them to understand the mathematics of a principal component analysis. That's not the point. They're never, you know, I've done that. I've courses on it, and I've taught courses, and I still don't understand the mathematics of a principal component analysis. But to be able to show them a picture and explain why things are in different regions of that plot, and to show them that these samples are the same and they're different than these samples, but you can see that they're together. That means those are grouping together, and that means that those two things are different. That's what they need to take away, not that, you know, the math of how you're doing varimax rotation and splitting up your principal component analysis. And that's the fun part, is trying to explain, provide visuals that are easy to understand, so that anybody can understand it. And if you can, there's, I don't know who said, is it Einstein that said that if you can't explain it in the simplest terms and you don't understand it yet, you have to be able to explain it in the simplest terms.
Yeah, I'd echo those sentiments. I think it gets, and give it time too. Like, I think, you know, depending on where you're at in your career, I can remember early on, like, really struggling to explain research that I was working on to, you know, friends and family members, which are great sounding boards for you to try out your science communication skills. If you see their eyes go cross-eyed and they, and they get nervous and fidgety or agitated when you can usually tell where people are coming from as far as how open they are to or receptive they are, or how concerned they are about the problem that you're working on, or how defensive they might be if they find it threatening. So I think science communication is incredibly important, and there's lots of great resources for scientists when it comes to improving science communication with the public. And I think, I mean, at a broader scale, at a broader scale, I'm concerned about ideological polarization. I think we all should be in Canada and in the US and the world. I mean, I think when you look at the science around COVID-19 and the pandemic and how it was used and misused and politicized, called a hoax at some points, and now it's sort of, even though your perspectives on the COVID epidemic tend to fall along political lines, and anytime you have issues falling along, largely political lines, there's a problem with polarization. And what I think, like, COVID is really in our face. It's affecting all of us right now. It's why we're on Zoom and not here in person. And you think of the tragic loss of life. There could be nothing more in our face and present, and the danger couldn't be more real. And yet it's still a real challenge to explain the science and the biology and the genetics behind COVID and the transmission and the risks and the costs and the personal freedoms and the liberties and all these issues that it raises. So I think it's it raises, the problem about global climate change is even more nuanced, more complex. It's a slower boil that by the time we get to the point where we are in the COVID pandemic, with climate change, it'll be too late to make effective changes. So we have to really use this as a wake-up call about how we are actually getting through to each other. Not just, everyone in this room is probably pretty receptive to the ideas that we're all talking about today, but we might be the choir, we might be preaching to ourselves. So we have to be really cognizant of how do we effectively reach out to other people who don't agree with us, who are predisposed to disagreeing with us just by, which office we sit in or what organization we work with or what our political leanings might be. So I think there's real challenges there, but believe me, there are real world successes that we can draw on, and to always try to end the story, the conversations on a positive note, pointing towards real world change that's already happened, using examples in the past for showing people and what we can do now, and not relying on doomsday, sort of narratives that are intended to scare people into acting, but always trying to bring the conversation back to try and finding common interests, common goals, places where we can agree, like getting away from left-right, politics and trying to refocus conversation on what the problem is and what are we all looking for here. Positive outcomes for children's education, healthcare for everyone, and a future that we can count on for future generations, and a sustainable future at that. So those are just some ideas I have on that issue.
And I'll just throw a quote. This is sitting on my desk, and it is inappropriate for scientists to let misinformation go unremarked. And I wrote this down because I think it's important for us as scientists and our role as scientists to help communicate. And whether it's COVID, whether it's climate change, whether it's sustainability, our job is to help communicate and educate, because as the panelists have said, like when it gets politicized and we have these, we're thinking along those lines, it's just crazy to think how this misinformation got, people believe in COVID based on their political alignment. That's crazy, but it happened. It's still happening.
So the next question is for Connie. What are the ways that awareness about green buildings can be made available to the general public? I myself do not know how to identify a green building.
I can help you with that. Give me a call. How do I identify a green building? Well, there's a lot of third-party certifications out there that a building might display, like LEED, which is Leadership for Energy and Environmental Design from the U.S. Green Building Council. So if a building has met the requirements for many different levels of being a sustainable building, they'll have a plaque in their in their lobby, as well as there's several other ones like that. But energy use transparency, the part of the problem is that we don't always know, right? When a building is green and what they're doing, but it behooves a business to brag about what they're doing, which is a lot of what I try to do for our members. You can go look on our website and see the buildings that are in our program that are working towards being more sustainable and greener. There's a lot of organizations like the U.S. Green Building Council and Well Buildings, which is another good one, that work on certification of buildings. So once you get into that information, it'll probably direct you to finding the green buildings. And green businesses is another good one. In Detroit, we have what's called the Detroit Green Map. I would really advise people to find the businesses in their area where they're at and support them. The ones that are promoting being a green business, hopefully they are. There's also the three, I'm sorry, I'm trying to think of the name of it. I've got it right here. You can, for a product, you can be, I'm trying to find the name of it. You can be a certified B corporation, this lotion, which means you're paying attention for people, planet, and profit, like triple bottom line of your company. So I would recommend when you find a company that takes that into consideration, that you utilize that company if you can, or that business, because then it helps those businesses get stronger. And I'd like to talk a little bit more. I think it was Court who said this about buying a lot of stuff and a lot of things. Hopefully you guys are the generation that's going to change this, but we're so used to consuming and buying. And there is a guy out there who wrote something about 10, 15 years ago about, you know, what it takes to make a product. And when you buy something really cheap, it's not sustainable, right? So you buy something for $1, it's like at the dollar store, where did it come from? How did they even get something made for $1? And then sell it for $1. You know, it's just thinking about that whole process about how something gets made, but buying less is a really good start for, I think, everybody.
Thank you, Connie. I think we are moving to the last audience question from Ed Verhamme, and he's asking this question from Dr. Sandau. What are your views on confidential data or results science that you do on legal cases, within bracket versus research and publication? How does this private knowledge reach other scientists?
Ooh, that's a good question. That's a difficult one. So obviously when you're dealing with confidential data with your clients, you can't just publish it. I can't even talk about most of the stuff I do for 5-6 years till the cases have all settled and all the dust is settled from the cases. But that being said, like there's two answers to that. One is I'm constantly pushing my clients to publish, and they're all, lawyers are very timid people. They're very scared about everything getting out there and someone using it against you. But I try to talk them down from the ledge and say, if I was to publish something on this, and then I went to the courtroom and said, here's my opinion, and by the way, I have a scientific paper that's published on it, and a bunch of scientists have read that and have acknowledged that it's acceptable, and it's been cited however many times, how much more is my opinion worth in a courtroom? And so I try to leverage that if I publish and I'm forthcoming in my information, and I have other scientists that have read it and approved it, that I think my opinion becomes a little bit stronger. So I try to encourage releasing that kind of information to the public that way. And then on the another thing that I'm just working on right now is we have a group of scientists that are working together on putting the best practices together for environmental forensic studies. How do you what's all the information you need? And the large majority of the members on that group that are putting that paper, those papers, 3 papers that are getting put together, are from consulting. are private industry researchers, PhDs in leading consulting companies that are putting their best practices. And I mention it almost every call, and they're probably sick of me mentioning it, is that I'm just dumbfounded that we're competitors. We're the ones that are going after each other in the courtroom and arguing whose opinion's the best. But we're actually working together on a publication to talk about what are the best practices when you're doing an environmental forensics investigation to say where something's coming from. So as a PhD scientist, I'm constantly trying to add to the literature and move science forward, because if we can't move it forward, we're sort of stuck. And instead of arguing about really what I think are really mundane and stupid things that should, I had a consulting company that didn't realize that, contaminants were related to total organic carbon in sediments. It's like, that was discovered in 1971. Like, are we still talking about this? Do I have to talk? Like, we have to move things forward so that we can talk about the real issues of, why is PFAS degrading in the environment, and why do certain patterns more predominant in some areas and not? And if we're still stuck on really old stuff, we're not moving forward. So I would say just, you got to publish, you got to keep pushing. And I don't think science isn't the thing we hide behind. It should be transparent. It should be unbiased. I live in an ideal world, and, I do wear rose-colored glasses, but that's the way I operate, is that, everything is open, and you should, one of my clients, I actually got him saying it, the science will set you free. If you know enough about the problem, you'll be able to explain what's going on and know what to do about it.
Perfect. Thanks for that answer. So unfortunately, that's going to be the last question we'll be able to get to today. But from all of us at both GLIER and TVAS programs, we would like to extend our thanks to our panel speakers and to all of the audience who attended. We appreciate the time you took out of your busy schedules to answer our questions and offer insight and advice to us graduate students. Please join us for our next seminar, which will take place on Friday, March 12th at 10 a.m. We hope to see you there. And again, the biggest thank you to Court, Connie, Paul, and Ed for just taking the time out to talk to us today. It was a really great discussion. I wish we had more time, because you guys have so much experience in such different career paths, but we really appreciate you taking the time you did today. So thank you.